Module 2 deals with the instruction sets of 8051, in which we have learned about the addressing modes and the data transfer instruction set and the arithmetic instruction set. And now will deal with the logic and compare instruction set. In logical instruction we have and logical and or and the XOR operations, in which and operation is performed on the four different addressing modes, in which accumulator is kept as the destination registers and source can be your immediate, direct and indirect addressing also. And in OR instruction, that is logical OR instructions, the syntax is ORL destination comma source, in which the destination byte should be always your accumulator and the source bytes can be your four different addressing modes, that is immediate, direct, indirect and the register addressing mode. Next, the XOR operation. In XOR operation, the syntax is XORL destination comma source. The destinations can be of should be accumulator, or next other type of source as destination is your direct addressing mode, and the source can be immediate, register, direct and indirect addressing modes. Example is taken, that is moving accumulator with a value of 404H and ORing ORL, that is ORing, that is logical OR operation of accumulator with 30H will give me a value of 34H. Next kind of logical operation is a complement accumulator, that is CPL accumulator. This instruction complements the contents of your accumulator. Next kind of instruction sets are the compare instructions. In compare instructions, CJ any destination comma source comma relative addressing. Here the destination and the source, along with it the relative addresses is specified. In this the flags affected are your carry flag will be affected. So the destination register should be always your accumulator and the source can be your immediate, direct or indirect addressing, and there should be a relative address specified so that the instruction points to that relative address within the program. Here is a simple program to show how CJ any instruction works. That is, we are moving the value 0FFH to your port 1 and moving the port 1 into the accumulator register. So it reads the accumulator will be having the value 0FFH. Now we have written a label, that is a subroutine, that is back colon CJNEA comma #99 comma back. Now back is your relative addressing. So what does this instruction do means the CJNEA comma #99 comma back instructions keeps monitoring the instruction till the loop comes out. That is, it executes the loop for 99 times and then it comes out of the loop. That is, CJNA is compare jump if not equal accumulator comma #99. So now accumulator is filled with the FFH. So it compares the accumulator to become 0 till accumulator becomes 0. The loop will be keep on monitoring. So these are the four kinds of addressing modes in which the CJ any instruction works. That is keeping accumulator as your destination, register as destination, and indirect addressing as a destination. Next set of instructions are the rotate instructions. In rotate instruction we have rotate left accumulator, rotate left with carry accumulator, rotate right accumulator, and next is a rotate right carry with accumulator. So this four kinds of instructions are being used to rotate it logically left, logically right, or to rotate the given instruction by keeping the carry. Next kind of instruction set are the branch instructions. In branch instruction there are three types of jump instruction. The jump instructions are also called as a branch instruction. So that is relative jump, short absolute jump and long absolute jump. The relative addressing jump with the new value for the program counter will be specified. So to that new value the program will be pointed. So the relative address can jump between 0 to 127, or when it jumps back the range is from -1 to -128. So these are the few jump instructions, that is jump with the, that is relative jump instructions, that is JC is jump with carry, with carry relative address will be specified. JNC is jump if not carry to that relative address. Next, CJNE is the compare jump if not equal to destination comma source comma relative address. It compares the destination source and it jumps to that relative addressing. DJNZ is decrement jump if not equal byte comma to that relative address. JZ is jump if to the relative address, jump if 0 to that relative address. JNZ is jump if not 0 to that. In the short absolute jump instruction, the lower 11 bits specifies the address for the instructions, and in the long absolute jump instruction, it accesses the entire program from 000h to FFFFH using the long absolute jump address. And in long absolute jump instruction, there are two kinds of jumps, that is unconditional jump and conditional jump. Unconditional jump is that in which the control is transferred unconditionally to the target location. Conditional jump is in which the jump is transferred to the specified address location within the program. So in unconditional jump there are three kinds of jumps, that is long jump, absolute jump and the short jump. Next the last kind of instruction set is the bit manipulation instruction. In the bit manipulation instruction, the port pins can also be addressed using this instruction, that is it includes the logical and. The syntax for logical and is ANL C, bit, in which logical